Hey everyone, if you missed class today, or if you attempted to get into class and the Google Meet did not work, this video is for you. So just a reminder, and many of you did that tried to get into the Google Meet. This is why that attendance is so helpful for me, because it shows me that you tried to get into the Google Meet even though it wasn't working. So thank you for doing that. Remember, only do that during your class period. So if you do it like 9 a.m. on a Monday, I'm like, nah, I'm not going to count you present for 6th period on Wednesday. If you need me to update your grade, let's say you turned in a late assignment, whatever, please click here on our class page. Again, this is where it's located, our class page, to let me know that I need to fix your grade. If you send me a Schoology message, it gets lost in an ocean of messages. And then everything we are working on is now just right up in front in a Unit 1 folder on our class page. So we do have a test next Thursday. What's on the test? The knowledge pyramid, which we'll talk a little bit about, variables, and graphing. How you can make a graph using your data to support your hypothesis. So let's look at this knowledge pyramid. So we're going to use a specific situation that we're all familiar with and apply it to this knowledge pyramid. So some time ago, people started realizing, oh gosh, St. Cloud Hospital, they have a lot of people hospitalized for a respiratory illness. At this point, we just have a number of people suffering from a similar respiratory illness. It's just data. There's no more information, no more connections. It's just data. It's just numbers. As time goes on, those numbers increased, and it followed a pattern. That pattern was how people pass it to other people. In other words, contraction. So now we have some more information. We don't just have numbers of people hospitalized. We have those people and their illnesses follow a pattern. We're seeing some similarities between them, connections. Then we can actually look at evidence. Now, evidence can be built a couple different ways, right? So there's testimonial. Maybe it's Dr. Fauci saying, okay, well, this is something we should be concerned about. This respiratory illness actually belongs to a family called coronavirus. So it's one person saying it, albeit he has lots of evidence backing him up, but if he's not presenting it, let's just say he's at like a board, meeting, whatever, it's testimonial evidence. He's saying it's true. Real evidence, that's when something you see is happening. So for me, about 2 weeks ago, maybe, my husband's family, they all came down with COVID-19. So when I was chatting with them on the phone on a video call, I could see they were suffering the symptoms that people had said were related to COVID. I could see their test results that were positive. So that's real evidence for me that I know, okay, pretty sure this respiratory illness is COVID-19. Demonstrative evidence is where people struggle a little bit. Remember, it has to do with those 4 R's. So is it robust? Is it reliable? Is it repeatable? So that has to do more with the maybe doctors, the researchers that are doing experiments that can repeat the experiment and say, yep, we know for sure after isolating this virus, it belongs in this family of coronaviruses and it's causing these symptoms. And here's what we think it transfers by. Now I put a question mark here because we still are learning more things about it. Even though we can come up with some knowledge about coronavirus and COVID-19 specifically, there's still more to know. So what knowledge is there? Well, from the evidence that we have so far, we know that there's steps to slow the spread of COVID-19. How do we get to that knowledge? Remember, we need a support of the claim. We need consensus. Consensus means everyone agrees on it. So that's using the knowledge pyramid with one specific example. Another way to look at it, if you're a visual person, I'm going to skip over this because it kind of takes a long time. I'm limited for time here on this screencastify, but I'll show it in the next slide. If you're a visual person, our data points, they're just random points of data. They don't mean anything yet until you start to see some sort of pattern. So in this case, we have some green dots, some purple dots. That's our pattern. It's pretty simple, but that's our pattern. Now we're building information. That information expands to knowledge when people can agree on the evidence. And that's where you get these connections, is people say, here's my real evidence that I saw, and then I can bring that to a doctor and say, well, yeah, my mother-in-law has a really bad cough. He can tell me COVID is a respiratory illness that affects the lungs. Okay, now we are going somewhere. We're building knowledge. Those are our 3 words from our pyramid. These words below are just kind of common in our language. So you'll hear someone say like, oh, it's great insight. That kind of, in a visual way, it's like you're jumping from point A to point B and skipping this whole path of knowledge. Wisdom, you're taking a path of knowledge, but your brain is finding the quickest way. And that's called wisdom. The conspiracy theory is not really real. It's just kind of funny. You're finding a pattern that may not actually be there. I know, it's a good joke. But essentially, each step builds from the previous step by building connections. So that's essentially what our knowledge pyramid is meant to do. So let's get down to the nitty-gritty, our variables. If I said my hypothesis was, I think that earbuds cause more hearing loss when listening to loud music, what would my dependent variable be and my independent variable be? You could pause and try to answer yourself. The dependent variable is going to be hearing loss. That's what I'm measuring. What's causing the hearing loss? You may think it's loud music, but in fact, what's causing it is the earbuds. According to this person's hypothesis and what their experiment will be, they're going to try to determine if the earbuds cause more hearing loss. So what's the control? Remember, the control is a run of the experiment without the independent variable. So if the independent variable is earbuds, the control is no earbuds. That'll make more sense as we move on. What about a constant? What needs to be the same if you were to do this experiment? Well, it says loud music, but I guess...
How do I submit it?
Okay, sorry, I had a student ask a question. All right, so what are constants? Well, if it says loud music, I would think that you would need to be more specific, right? So the constant, whether you're going to have someone listen to music with earbuds or no earbuds, needs to be the same volume of music and maybe the same type of music. I would say you're going to test the same person, right? Because people's hearing will change. So those are just some examples of constants. Now let's look at the data. Now you'll see right away, Ms. H, this is all wrong. I know, I should change that. Keep forgetting to change that. The dependent variable is hearing loss. So it should say up here, hearing loss. The independent variable, what's causing the hearing loss, is earbuds or no earbuds. Now, according to this data, does it support this person's hypothesis? Yeah. They said my hypothesis is earbuds cause more hearing loss when listening to loud music. So this is more hearing loss than without earbuds. Let's put that in a graph. So I know my independent variable is earbuds. My dependent, what I'm measuring is hearing loss. Where do they go in my graph? My independent variable always goes on the bottom. So I'll have earbuds or no earbuds. My dependent always goes on the side. That's what I'm measuring, is hearing loss, right? And then I can't forget about my title. So why is this a bar graph and not a line graph? Could this be a line graph? Would that still make sense to you? Well, let's look at the hypothesis a different way. This is a whole different hypothesis. I think hearing loss increases as volume increases. What's my dependent variable and what's my independent variable? Go ahead and take a pause. My dependent variable is still hearing loss, but my independent variable now is volume. Volume is what's going to cause hearing loss according to this hypothesis. Let's look at the data. Hearing loss is my dependent. That's what I'm measuring here. That's why it's over here. And then my independent is volume. As you can see, according to my hypothesis, the hearing loss should increase as volume increases. So I will see that the volume increases. How much does it increase by? By 5. 5, 10, 15. Let's look at our graph. So if my independent is volume increases, where does that go? On the bottom. My dependent is hearing loss. That goes to the side. It is going to be a line graph. Why is it a line graph and not a bar graph? How do we tell the difference between line and bar? Let's say you have your own data to sort through and make a graph. How are you going to decide if it's line graph or a bar graph? Here you can find a cheat sheet. Now that's in your class folder. I'll also put it in your study guide folder. You can refer to this. But this will help you determine if it's going to be a line graph or a bar graph. There are a couple questions you got to ask yourself. What is the independent variable first? Well, in this case, the independent variable would be volume. So is the independent variable time? No, it's volume. So I go here, follow the chart. Does the independent variable change in equal intervals? Well, if I remember correctly, I changed that volume by 5. So I started at 5, I went to 10, and then I cranked it up to 15. So yes, it does go up in equal intervals. That's why it's a line graph. Now, you can use this cheat sheet whenever you're stuck or it doesn't make sense. Sometimes these graphs will just come intuitively or rapidly to your brain. So you may not always need that, but it's there for you to use. So hopefully that helps determine if it's going to be a line graph or bar graph.